Hi, and welcome to another episode of Learning Electronic with Richard. In this episode, we're going to talk about serial communication between a microcontroller, in this case Arduino, and a computer through Xbee. We're going to talk about why we use it and how we use it. Now, you've all heard about parallel communication. Serial communication versus parallel communication. The serial communication advantage is that it can achieve a higher rate than parallel because it has less parallel lines, so it has less interference. You can also clock data faster than the parallel transfer. The common serial transfer rate is also known as the baud rate. There are 2400, 4800, all the way up to 11, 5200, and these are the common ones that we can pick from. The units are in bits per second. Now, the baud rates are not entirely data transfer rates. Serial communication also includes other signals, including the formatting bits like the start bit, the stop bit, and the error checking bits. These bits are presented to ensure the data transfer are correct. So for one start bit, 8 data bits, and one stop bit, no error checking bits, the data rate is 8/10 of the entire bit transfer. So it's transferring data at 80% of the baud rate. This is what an Xbee transmitter receiver looks like. And this is what a receiver looks like when you hook up to a computer. They're identical chips, just configured differently. Data are transferred wirelessly at 2.4 GHz, but that's not our concern today. We use it to transfer data serially. So now you ask, how do we connect them? It's super easy. We connect the serial pin, the serial TX, which is the transfer pin of the Arduino, to the receiver pin of the Xbee. And we connect the receiver pin of the Arduino connect to the transfer pin of the Xbee. As easy as that. And don't forget to power the Xbee with 3.3 volt and the ground. The following is a simple Arduino code required to transmit data. We set the baud rate at 4800, use the built-in library to send serial data by calling serial.println, and include the string you want to send. Let's check at the receiver end. As you can see, there are 3 types of programs that we can use to receive. For example, hyperterminal, PuTTY, or a customized Python script. In this case, we're using a Python script because it's very simple and it also helps us understand how serial communication actually works. It also allows us to write the data to a file or do operations on it. As you can see here, we configure our data rate to be 4800 and we specify our port, in this case is COM7. Here we also specify how many start bits, stop bits, and error checking bits we're using. Also the data bits. In this case, we're using 8 data bits per transfer. Here we print out the text that we receive, and let's see what happens at the receiver end. Look, this is the result of receiving those transfer strings in Python. The Python script shows hello and world, which is the strings we transfer from Arduino. So this is telling us that our program is receiving correctly and we're transmitting correctly as well. That's it for this tutorial. Subscribe for more tutorial videos in the future. See you next time.